Hey everyone! In the previous lessons, we learned some very important concepts of machine learning. We started working with our first statistical model, which was KNN. So we learned how to use KNN to make a prediction, to predict the species of an iris flower based on its measurements. Then we learned how to split data into training and testing groups. We learned how to measure the performance of the model. And we learned how to choose the best value for K. But now our job is not done because we don't know if KNN is the best statistical model for our problem, for our data set. So in this lesson, I'm going to show you another statistical model called Logistic Regression. Logistic regression is used in machine learning for categoric predictions. What we've been doing so far is an example of categoric prediction. We are trying to classify the species of an iris flower. Another example will be, is an email a spam? So we have two answers, yes or no. So this is a categoric problem. What is the species of a plant? A, B, or C, like we are doing with the iris dataset. So those are all examples of categoric predictions. The logistic regression model is better suited for binary classifications, in which we have only two possible answers. So the spam email is an example of a binary classification, which is not the case for the iris dataset. So before seeing how we can use this with the iris dataset, let's imagine a binary problem so we can see how logistic regression works. So let's assume we have only two possible species of a plant. So in the y-axis, we are always going to have values 0 and 1 with the logistic regression. And in this example, in the x-axis, we have the petal length. So distributing our data into this chart, we would have something like this. So we have the petal length, and we have species 0 and species 1. So what we're trying to do is defining the likelihood of a new observation to be of species 0 or species 1. So how can we do this? Well, this model is going to generate an S-shaped line like this. So then, for this new observation, we know that there's a 70% likelihood of it being of species 1. So this is how this model works. So how is this going to work with more than two variables? For that, we are going to use a method called one versus all. So to understand how this method works, let's first draw the first chart, which is going to be setosa versus all. So here we have all the species, and 0 means that it's not setosa, so it's either virginica or versicolor. And 1 means that it is setosa. So for this new observation would have a 35% likelihood of being setosa. Now we are going to do the same thing for the other two species. So this time we have virginica versus all. So 0 means it's not virginica and 1 means it is virginica. This time we have a 12% likelihood of being virginica. And we do the same thing for versicolor, which in this case has a probability of 65%. So the higher probability is for versicolor, so in this case the computer would predict that this new observation is a versicolor. So this is how we can work with more than two variables with the logistic regression. Of course, in this example we are only showing petal length, but a computer is going to do the same thing for all measurements and then come up with the final prediction. This is going to be very clear when we apply it to the iris dataset. So this is exactly what we are going to do in the next video. I'll see you then.